All right, lovelies, we are doing grade 7, lesson 1-6. Our I can statement for today is that I can make scale drawings and use them to find actual dimensions. So we'll go from a scale drawing, like a map, and then go to those actual real life dimensions. All right, here is our word problem. Locust Grove Township is building a new swimming pool using the scale drawing shown. How many meters of pool length does a scale drawing length of 7.5 inches represent? And then the second question is, what is the scale drawing length that represents an actual length of 75 meters? So we actually have two different questions that we're trying to answer. The first one is wanting to find our scale drawing length of 7.5 inches. What does that represent? And then going to, from an actual length of 75, what is that in the scale? So essentially what we're trying to do is continue our graph here. Continue our graph to have two more points. One of them is when we have a scale drawing of 7.5. What is that in actual length? And then the reverse of that is 75 meters. These are inches. Meters. And then what is, get some question marks in here. What is the drawing length? What is that scale drawing length? So first we need to find the scale between the drawing and the pool. So we're essentially kind of finding our K here. So we're going to take our table here and we're doing 2 to 8, 3 to 12, 5 to 20. And when we simplify those, what do all of these fractions simplify to? Yeah, it's going to be 1 inch for every 4 meters. 1 inch for every 4 meters is our ratio here. So 1 inch to 4 meters is our scale. And now they want to have us write an equation. Now I've gotten questions before about why is the 1 inch on top and the 4 meters on bottom. This is where it gives us that info of which one needs to go where. So here it wants us to have our actual length as our x. So this is our x is this side. And then our y is our drawing length. That's in our inches. So our drawing length is our y. And this is just something to keep an eye on because this is just different. Normally our x is first and then our y is listed second. But here our x is in our second column. So just be aware of that. And then we need to write an equation. So that is our y equals kx, where our y is talking about our inches and our x is talking about our meters. And I'm getting that information from right here. We found our k, our rate of change, that scale between the drawing and the pool, and that's going to be 1/4. So we're taking our eraser here, getting rid of our k, and plugging in our 1/4. Now that we have an equation, we're able to solve, going back up here to our question in our yellow highlighted and our pink highlighted. We can finish our table with those question marks. So use the equation to find the actual length represented by a scale drawing of 7.5 inches. So taking our equation, y equals 1/4 x, and here we're plugging in 7.5 inches. That's what we're substituting in. So again, our inches are on this side. So that means I'm getting rid of my oops, getting rid of my y here, equals 1/4 x, and I'm plugging in my 7.5. Now we're trying to figure out the value of x. I'm trying to figure out the value of x, and we'll get into equations in later modules, but here we can think a little more conceptually. What times 1/4, or what number when it's divided by 4 will be 7.5? So we kind of think inverse. So if it's a big number divided by 4, what we can do is try and multiply both sides by 4, and that will give us this value of x, because this x should be a pretty big number, because it needs to be divided by 4 to equal our 7.5. So on the side of your paper, let's do a little multiplying. Give you a minute to do that. Don't forget that decimal. So 7.5 times 4. And that answer for our x, and again our x is our actual length here, so I can get my eraser here, get rid of this question mark. When we do 7 5/10 times 4, that is going to equal 30. That will equal 30. We would have our 5 times 4 is 20. 28 plus 2 is 30. And then we can't forget our decimal here. So we're going to have x equals 30. Now, like we were saying yesterday, or with the previous lessons, what is 30 talking about? What are you answering? Is this meters? Is this inches? What is the 30 referring to? Try and put that into a sentence. 30 what? So we know when we plug in our 7.5, that's talking about our inches. It's talking about our inches here. So when a scale drawing, going back to our table here, is 7.5 inches, the actual length in real life, in person, 7.5 inches in a map will equate to 30 meters in real life. So the flip side of that, we need to figure out what the scale drawing is when the actual length is 7.5. So let's take our initial equation again with our k value. Now instead of plugging in for y with our inches, we're going to want to go over to our meters, because that's what's given. We're given 75 meters and we're trying to figure out our inches. So on this side, I'm going to substitute in 1/4, and then my x is 75. Y equals 75 divided by 4. Again, let's do that on the side of our paper. If you need to, do your decimal. Don't forget to bring it up. And then put it into a sentence. When we get there, what is that referring to? We know our meters. So that means we're trying to figure out our inches, our scale drawing length. When we do our division, 4 goes into 7 once. There's 3 left over. 8 times 4 is 32. Bring down my 0 one more time. 7. 28, we're getting a little closer here. I'm going to bring down another 0. And 4 goes into 20 nice and evenly 5 times. So when we have an actual length of 75 meters, the scale drawing will be 8.75 inches. So going back up to our table here, we can plug in our 8.75 inches.